Okay, so let's start. This is Newton's laws of motion, and today we'll do the PYQs. It's grade 11th, and the date of lecture is 12th of Jan 2024. Is that okay? Let's start. So, see, the objective of doing these PYQ sessions is you get the insight of your exam. If you have this thing, na, ki we are going to do a numerical session, we're going to deal with these kind of questions. So if you familiarize with your paper, na, it is very, very important for you because it brings a lot of confidence while in that real scenario. When you're sitting to take the exam, you're doing it. If you still, know the outer line of your paper, now you will be very comfortable. You will be very confident about that paper. Okay. And this is my suggestion for you all also. Ki, bhai, please do the questions. Do the PYQs as many times as you can. Okay, revise them even, I would say. Because PYQs and syllabus, these two things are the only important key to clear any exam. If you have the guidance, if you have the exact way to follow, you will achieve the goal. Yes or no? So these sessions are very, very important. And this slide actually explaining that thing. Let's come to the next one. As I've discussed this thing with you also, that in last 5 years we have seen 8 number of questions from this chapter. Okay, so if you do a very simple basic mathematics, you can get the idea that sometimes it is skipped, but sometimes it is there for like more than 2 questions are also there. So this is very important for us. And I believe that in the last class, sorry, not in the last class, in the last year, we got 3 questions from this topic. Okay, so 3 questions means 12 marks, and we cannot ignore this. Is that okay? See, I have told you this thing like zillion of times. Please interact in this class, make it as interactive as it can be. Okay, please open your mic, do the chat, do something. I don't like a class like this. We are not talking, we are not doing conversation. Yeah, thank you. Thank you for reactions. Good. So I think in the last class, I gave you a one shot of this chapter. Let me revise few important points out of that. Can you, okay, let's just start. You gave me the insight of that lecture. Newton's laws of motion. So basically, how many laws do we have?
3 laws.
Three.
Okay. So can you explain me the first law?
Law of inertia.
Very nice, Harshita. Law of inertia. And what about the second one?
Law of force.
Exactly. And for that, I would go with this expression because it is the crux of that law. Let's come to the third one. What is third law?
Action and reaction force both act simultaneously.
And on the different bodies, right?
Yes.
Cool. Now, what do we mean by linear momentum? Anyone? What is linear momentum?
Mass into
It is
velocity.
a product of mass and velocity.
Product of mass and velocity.
Right. And I said, if external force is zero, then linear momentum would become constant. And this property is known as conservation of linear momentum, right?
Yes, ma'am.
Okay. And besides it, what we have discussed is all about the forces, right? All the forces that we have. I think I told you about the 5 forces. I remember. Can you explain me just the name of those forces? Because I've already told you how to deal with those forces. Anyone? besides Harshita and Jennifer? Please, someone else. I really want new names over here. Divisha, can you help me with the courses? Okay, Miss I'll come to you. Divisha, you can even say, ki, ma'am, no, I want to skip. And that is okay. Please respond either on the chat or on the mic. Okay, she's not talking. Okay, Namrata. ठीक है, Namrata. Let's start. Give me two forces. Give me the name of two forces.
Gravitational force.
No, Harshita, not you. Namrata.
Gravitational force,
Hmm?
tension force, normal
Okay,
force,
that's it, Namrata. Very good. Gravitational force. And the second one that she said is tension. Very nice. Namrata ke baad. Misbah, are you there? I think she's not the. Yes, Rajeshwari.
Some normal force. Spring force.
Okay.
Frictional
Normal
force.
force and
Spring force.
very good. Spring force.
Frictional force.
Which one? Friction
Frictional.
force. Okay.
I'm
Very
not
good.
answering. I'm Gayatri.
Oh, okay, Gayatri. Okay. Cool. So very nice. And I think this is a very nice recap of that lecture. Now we will start with the questions. And for the questions, I want to tell you one thing. Ki I will launch the poll for every question. You can find find that poll in the activity area of this Google Meet. Okay? Do cast your vote over there only. There is no other way to give me the answers. You are not allowed to open your mic and share your answer or not even the chat. I want everyone to cast the vote on the poll. Okay, I'll going to give you a time limit, and for every question, I'll give you on an average 1 minute. Okay, we need to answer every question within the 1 minute, and you will only vote on the poll. Okay, just cast a vote on the poll. That's it. Yeah. So this is the question of 2009. Let me read it for you. This question said, a body under the action of a force this. The force is F is equals to 6 I cap minus 8J cap plus 10K cap. Okay, I'll write it here. The force is 6 I cap minus 8J cap plus 10K cap. Okay. It acquires an acceleration of 1 meter per second square. The question is, can you find the value of mass? You have four options over here: 10 kg, 20 kg, 10 root 2 kg, and 2 root 10 kg. So it's 17, 15, sorry, it's 18 right now. You will have 1 minute to solve this question, and I'm going to launch the poll. See, poll is live now. Kindly answer over there. Okay, time is up, and I got only 2 votes. Not appreciated, not at all. You all are supposed to answer this question. Okay, anyway, I'm ending the poll. I'm showing you the result. Both of them tick option C. Let's check. See, they are asking you about the mass. You know, from Newton's second law, okay, from Newton's second law, what we have, that F is equals to ma.
Mass into acceleration.
Exactly. Now they are asking you about this scalar quantity. Now, so it would be the magnitude of force and the acceleration. Okay. So for that, you need to find out the magnitude of this vector.
Magnitude of force.
And it is always under root x square, y square, z square. You add those coefficients of I cap, j cap, and k cap. Okay. So it would become the square of 6 plus the
8
square of
square
8 plus
plus
10
10
square.
square.
Multiplied, divided by acceleration
1
1. Okay, just solve this. It would become 6 square is 36, 36 plus
100.
64. 36 plus 64 is
100
100, 200. It would become 10 root 2. Since it's 1 in the denominator, so this would be your answer. And they are very, very, they attempted it correctly. It's option C. Very good. It's your option C. Let's come to the next question. It is a PYQ from 2014. And again, I'll read it out for you. Question said, the force F acting on a particle and it is indicated by a force time graph. You have a force time graph over here. You need to find out the change in the momentum. Okay. Change in momentum from 0 to 8 seconds. Let me mark few things over here. This is 0. This point is 6. Again, this is 0. This is negative of 3. And it is also negative of 3. Here you have 2. You will have here 4. And this point is 3. And this is 8. Okay. So I marked all the important points. Force is on the y-axis and time is on the x-axis. Okay. Now you have, it is 18:03 right now. Kindly cast your vote within the given time. Okay. I'm launching the poll. See, poll is live. You can vote over there. Okay, I'm ending the poll because time is up. And now I've got 3 votes. Okay, it's an increment. I think I would be happy then. The answer is reflecting to you also. You can see that 2 people opt the option A and 1 goes with the option C. Let's check. So they are asking you about the impulse, right? See, impulse is F into T basically, right? Change in momentum. So when you have a curve of F versus T, basically you will get impulse out of that from area under the curve. Since this impulse is a vector quantity, so we need to be very cautious about the positive area or the negative area. Okay. So now just calculate the area under the curve. And in this process, you will get area of triangle, then
area of
area of a
rectangle.
square. See, area of a square is in the negative axis, right? Square is
Minus
in the negative axis. Yes, it has to be negative. You are supposed to subtract this area of the square, and add the area of rectangle, right? That's it. So area of triangle is half into base into height. The base is 2 and the height is 6. Is that okay?
Yes, ma'am.
See, this is the base and this is the height. So it is 2 into 6. So half into 2 into 6 minus. When it comes to area of rectangle, it would become, sorry, area of a square. It would become side ka square of the side. So basically, this is 2 and again this is also 2. So 2 ka square, right? It is 2 now. No. Even this is not the square. This is the
Ma'am, it's
rectangle also.
rectangle.
Yes, it's 3 into 2. Yes. So it's 3 into 2. I think you will get an idea ki what I'm talking about. Should I mention the naming like A, B, C, D, E? You get the idea. Hmm? Take care, but he didn't reply like that. So this is the origin. Let's say O. This is A. This is B. It is C. It is D. It is E. It is F. Okay. And this one is E, F, G, H. Okay. That's like, so it is C, B, E, D. This is C, B, E, D. Now it is fine. Let's come to the area of another rectangle, which is in the positive axis. That's why we need to add it. And it is also 3 multiplied by 4. Okay. That's it. Solve this question. So 6 minus 6 is going to cancel out and you will get 12 as your answer. So it will be 12 Newton second. Option C. That one kid is correct. Can that kid raises his or her hand? Who voted for 6? Very good, Harshita. Very nice. Very nice. Okay, though we got 2 hands, but I think the vote is 1, na? Koini, I'll check it because I get the Excel sheet out of all of the responses that you are going to, you are making. I'll get the Excel sheet out of it. So I'll check ki who's voting correctly and how many people are, giving the answer within the time, everything. This is a question from Mains 2012, and the question is like this: ki a stone is dropped from a height h. It hits the ground with a certain momentum p. If the same stone is dropped from a height 100% more than previous height, the momentum when it hits the ground will change by. Please make sure that you read this question very carefully. Because if you answer that new momentum, it is not going to be the correct. They're asking you about the change. Okay. So language is supposed to be very important in these kind of questions. It is 18:09 right now. You have 1 minute to solve this question. And I'm going to launch the poll. Okay, it's 18:10 right now. So you will have 18:11. Okay. The poll is live. Kindly answer over there. Okay, time is up. And okay, I'm ending the poll with 3 votes. 2 votes for option B and 1 vote for option D. Let's check which one is correct. So in this case, you need to make actually 2 scenarios. There are 2 scenarios. Case number 1, when initial velocity is 0, the acceleration would be negative of since these bodies are moving under the influence of Earth, right? Let's
Yes,
say
ma'am.
displacement is equals to h in the case number 1. Okay, so you can find the velocity. which would become b square u square plus 2a from this equation. So it would become
I have
2g.
not understood the question.
What?
I have not understood the question.
Okay. See, the question is, we have dropped a stone from a height h. Okay. In the next case, I increase the height 100%, which it means that I dropped the stone from 2h height. In both the situations, initial velocity is going to be zero, and both of these motions are going to be under the influence of Earth, right? Under the influence of gravity. So the question is, find the change of momentum when they hit the ground. So you are supposed to calculate the momentum in case number 1 when the height is h. Then you will find the momentum in case number 2 when the height is 2h and calculate the change. Is that okay?
Okay,
Basically,
ma'am.
percentage of change. Okay. So V would become root 2 GH here. You would say, ma'am, why are we not taking this minus? So then this H is also negative now, because displacement is also a vector quantity. And from initial to final, that is how we are going to draw that vector, right? It is also negative. So we will get basically V is equals to root 2 GH. Is that fine? Okay. Let's do this much calculation for case second also. For case second, u is equals to 0, acceleration is equals to negative of g. Okay, can you please open your cameras? Just switch on your camera. Okay? This is the time, as I already told you. Please do that. So in the case second, you have u0, acceleration negative of g, s negative of 2h, right? Yes, please. Just make sure ki, I can see your faces, right? We need to click a selfie. Not a selfie in a very legit manner, but a screenshot. Okay, please do that. So in case second, you have initial velocity 0, acceleration is negative of g, s is equals to minus of 2h. Yes, I'm seeing people are doing it. That's very nice. Shikha did, Rajesh with Gayatri did, Harshita, Namrata, everyone please do it. Okay, Jennifer did. That's cool. At least, but this way I can see you now. Otherwise, I've never seen you guys. Yeah,
मैम
Vishnu did.
हेलो मैम, आप एक बार स्क्रीन प्रेजेंट को रोक दीजिए तो बच्चों का सभी का फेस आ जाएगा स्क्रीन पर.
Okay, I'll do that. Okay. So, yeah.
जस्ट अच्छा बच्चों, ये बताइए आप सभी को आपका सिलेबस मिल गया है ना? जो भी आपका एग्जाम है संडे, मिल गया है ना सभी को? ठीक है. अच्छा, पहले ये बताइए आप सभी कि आप सभी को कॉल जाता है किसी का अवंती की तरफ से, तो कितने बच्चे आप हमारा नाम जानते हैं बताइए. इरफान, ठीक है. अभी कुछ बच्चे और हैं जिनका अभी कैमरा ऑफ है. बच्चे आप भी कैमरा ऑन कर लीजिए. सभी बच्चे कोशिश कर लीजिए कैमरा ऑन करने के लिए. अच्छा,
You
कितने
can use
बच्चे?
filters, okay,
यस.
if you want.
अच्छा, ये बताइए कितने बच्चे हमारा नाम जानते हैं, ये बताइए माइक ऑन करके एक बार. कोई नहीं जानता? नहीं. अच्छा, किसी को कॉल गया है मोहित के नाम से कि आपको कॉल किया गया है अवंती फेलोज की तरफ से?
Yes, sir.
हाँ, मतलब कुछ बच्चों को गया होगा, हो सकता है कुछ बच्चों को नहीं गया हो, बट हम लोग कोशिश कर रहे हैं कि सभी बच्चों के पास में कॉल जाए. अच्छा, सभी को अपना सिलेबस मिल गया है ना संडे टेस्ट के लिए?
Yes, sir. Yes, sir.
तो संडे सभी बच्चों को टेस्ट देना कंपलसरी है. और अभी हम अपनी स्क्रीन शेयर करके आपको कुछ पॉइंट्स बता रहे हैं जो कि आपको कल संडे टेस्ट, मतलब जो भी संडे टेस्ट आपका 14 तारीख को, उसके अंदर आपको फॉलो करनी है. ठीक है. तो ये कुछ हमारे पास में स्टेप्स हैं. आपका नीट का है ना?
Yes, sir.
ठीक है. जस्ट अभी हमने स्क्रीन शेयर कर देते हैं एक बार. कोशिश करना आप सभी बच्चे कि आप ये सारी चीजें ना फॉलो कर पाए. अभी बताना आपको हमारी स्क्रीन विजिबल हुई क्या? जस्ट एक सेकेंड. सभी को स्क्रीन विजिबल है ना?
Yes.
यस सर.
तो बताइए सभी को अपना एग्जाम का सिलेबस दिख रहा है ना, टेस्ट सिलेबस सबका?
Yes, sir.
ठीक। तो आपको फॉलो ये करना है कि जो आपका एग्जाम है, टेस्ट है, उसके अंदर इंपॉर्टेंट नोटिस आपके लिए क्या है कि आप सभी को ना अपना स्टूडेंट टेस्ट स्कोर स्क्रीनशॉट्स, जब आप सभी अपना टेस्ट दे देंगे तो आप सभी को अपना स्क्रीनशॉट, जो भी आपका स्कोर हुआ है, जितने भी क्वेश्चंस आपने अटेम्प्ट किए हैं, आपको एक स्क्रीनशॉट हमें जरूर व्हाट्सअप करना है। ठीक है। दूसरा क्या है कि जब आप संडे टेस्ट दे रहे होंगे तो आप अपना फोटो भी एक ले सकते, मतलब फोटो सभी को लेना है, जो कि आपके पेरेंट्स या फिर आपके छोटे बड़े भाई बहन वो आपको फोटो ले रहे टेस्ट देते वक्त कि आप कहाँ बैठकर किस तरीके से टेस्ट दे रहे थे, कि आपके पास में कोई बुक्स वगैरह तो नहीं थी। अब वो मतलब थोड़ा सा आपको वैसा लग रहा होगा कि सर बुक्स तो हम पहले रख लेंगे, बाद में मतलब जब फोटो खींचेगा तो हटा देंगे, फिर रख के टेस्ट दे सकते नहीं। मतलब आपको एक ऐसी जगह बैठ करके एग्जाम देना जैसे कि आप एक एग्जाम देने के लिए हॉल में जाते हैं, तो आप अपने पास बुक्स वगैरह मत रखना, आप सिर्फ अपना एग्जाम देना अपने तरीके से। ठीक है। ये दोनों फोटोज हमें चाहिए होंगे आपके। बोले इतना क्लियर बच्चे सभी को?
Yes, sir.
ठीक है। अब आपको ये व्हाट्सअप कहाँ करना है, किसके साथ शेयर करना है? ये आप सभी को हमारे साथ शेयर करना है। हम आपको जस्ट अपना नंबर चैट सेक्शन के अंदर दे देते हैं। ठीक है।
Gayatri, I'll reshare this information. Don't worry. So this information is very simple, Gayatri. You need to follow few instructions while taking the exam of 14 Jan, right? First, you need to take the screenshot of your scorecard, and then somebody else from your home, whether it could be your parents, it could be your brother, sister, they will click a photo of you while you are taking that exam. Okay? So make sure that you are not keeping any kind of books or notes with you, helping books. You're not supposed to do that. Okay? Gayatri, have you got it?
Yes, ma'am.
Okay.
ठीक है। तो
Cool.
आप सभी को ना चैट सेक्शन के अंदर नंबर दे दिया है हमने अपना, तो आप वहां पर व्हाट्सअप कर सकते हैं अपने सारे स्क्रीनशॉट्स। मैम आप कंटिन्यू कर लीजिए अभी।
Okay, sir. So basically, sir have dropped the number, his number in that, in the chat section. You are supposed to drop your screenshot in that photo on that particular number. Is that fine?
Yes, ma'am.
Okay.
Yes, ma'am.
Baki, as he is asking, do you know his name? So I will also ask, do you know my name now? It is
Yes,
fine,
ma'am.
na?
Yes, ma'am.
And cool. Take it. So if you're comfortable, then it's very nice. You can open your camera because that would make this class very lively. Okay. So I would love that. Basically, let's start with this case. So in this case, S is equals to H. Okay. In the case number 1, you've got this velocity. Now we are doing the same, procedure for the case second also. And in this case, you will get velocity 2g2h, right? It would become 4gh. Yes or no?
Yes, ma'am.
So basically, it is root 2 times of root 2gh. Remember one thing, whenever you are supposed to calculate the change, okay, so try to frame your expression in the terms of previous one. So in the previous one, I got root 2gh. That's why I write it like this: root 2 times of root 2gh. Okay, the main reason behind it I can write v prime as root 2 times of v. So do you get the point?
Yes, ma'am.
Okay. Once I got this expression, I can write the change in momentum, because change in momentum would be m v prime minus v. So it would become what? M root 2 minus 1 v, right? Now root 2 is what? 1.41. So if you subtract 1 from it, so you will get 0.41 times of v. So this is the amount of change in the momentum. Once you got this, you can calculate the percentage. See, percentage would be delta p by p into 100. And it would become 0.41 times of 100, which would be 41 something percent. So you can correct, it's option B. Okay? It is your option B. Is that fine?
Yes, ma'am.
Have you got it, Harshita? You find it difficult now? Okay, that's cool. Cool. Let's come to the another question. And it is from 2008. Again, I will going to read this question for you. The question is: sand is being dropped on a conveyor belt at the rate of m kgs per second. It means there is a moving belt on which we are dropping m kilogram of sand in every second. Are you getting my point? We are dropping sand of m kg per second. This is the information that you have. Now, the force necessary to keep the belt moving with a constant velocity of v meter per second will be. We want that that belt will move with a constant velocity. Even we are dropping the weight in every second. Okay? You know, na, it's very hard to move a massive object comparison to the lighter one. So if you are continuously increasing the mass of that belt, you need to increase the force as well in order to move it with a constant velocity. Otherwise, it will going to drop. Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay. So it's 18:22 right now. You can solve this question. Oh, it's not 10 minutes. You can solve this question within 1 minute, and I'm going to launch a poll. Okay? Answer over there. So poll has ended, and result is live for you also. I've got 3 votes, and all of them is for option C. That's very nice. I like this convergence. You are converging to a option only, because in a lot of batches I got a spectrum of answers. Like kids will answer to every option literally. So this is very nice. Ki we are at least getting a particular option. Although we have a sample size very small because you are just 10, 11 students here. Take care. So in this question, we need to deal it with the basic definition of second law, or should I say the fundamental form of the second law, that F external is equals to dp by dt, differentiation of momentum with respect to time. You can write it as wait a minute. Okay, just I think my screen got stuck. Yeah, now it's stuck. So d by dt of m into v. Okay, we can write it as like this na, m dv by dt plus v dm by dt, right? Since in this
Yes,
question
ma'am.
you have a particular information given to you that we want a constant velocity, in that order the dv by dt is going to be 0 now. So this external force would become v times of rate of change of mass, and rate of change of mass is m. So basically you need to apply this much of force in order to move that belt with a constant velocity. Okay, and this is your option C. Is that okay?
Yes, ma'am.
Yes, ma'am.
That's good. Let's come to question number 5. Okay, I'm going to give it you in the homework because I really want to give you nice questions. Okay, we have actually deal a question like this, so that's why I'm giving you this question in homework. Yes, go for question 6. Question 6 is a nice one. It is a PYQ from 2016, and it said a rigid ball of mass m strikes a rigid wall at 60 degree. Okay, we just throw a ball at the wall at 60 degree angle with the horizontal. It gets reflected without the loss of speed. Okay, without loss of speed, as shown in this figure, the value of the impulse imparted by the ball on the ball will be. We need to find out the impulse. I will draw this diagram here for you. If you find it difficult to study over there. This is the ball that we have. This is the ball that we have. And we strike it like this. Okay. It is making 60 degree like this. And it get reflected and also making the angle 60 degree. Is that okay? this is striking with v velocity, and since the question said there is no loss of speed, so it will get getting reflected also with the v velocity. Is that fine with the v speed? So it's 1826 right now. Solve it within 1827, and I'm going to launch the poll. Okay, I'm ending the poll. The answer is live for you also. Let's do this question. See, it is a very simple question. You just need to find out the initial momentum vector and the final momentum vector. For impulse, basically the change of momentum, na? So we need to find out the initial and final one. Yes or no?
Yes, ma'am.
Yes, ma'am.
Cool.
Yes, ma'am.
So let's draw that. Instead of this ball, I'm going to draw a Cartesian coordinate. Okay. Because I need to draw the vectors. As per the given condition, the initial velocity is like this, na? Like this. This is initial velocity vector, na? Making 60
Yes,
degree
ma'am.
with the wall. Okay. And let me draw this final one with another, ink. It is 60 degree like this, and it would be this. So just draw the vertically opposite angles. And I think this would be your 60 degree. And for this blue wala vector, you will get ding and ding. This is 60 degree, right? Vertically opposite angles. Okay. Cool.
Yes, ma'am.
Just resolve the vectors. So when I will resolve this, I will get a negative in negative y. I will get v, and it says v, it says v. I will get v sine 60 degree, na?
Yes, ma'am.
Yes. So I will get v sine 60 degree in this direction, and I will get v cos 60 degree in this direction. So the initial momentum vector would become m v sine 60 degree in negative y and v cos 60 degree in the positive x. So what is the value of cos 60 degree? 1 by 2.
1/2.
So it
Yes,
will
ma'am.
become mv by 2 I cap. Since the y component of velocity vector, initial velocity vector is in negative y, so I will write negative over here. Sine 60 degrees root 3 by 2, and I will get root 3 v by 2 j cap. Is that okay? This is your initial
Yes,
momentum
ma'am.
vector. Let's resolve the final one. So you will get a negative component in x direction, and it would become v cos 60 degree. You will get a negative one in y direction also, and it would be your v sine 60 degree. Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay. So your final momentum vector would become m v by 2 I cap of negative, negative 1. Negative of root 3 by 2 v j cap. Just calculate the change in momentum, and it would become, I guess, p final minus p initial, right? Just subtract it. So the I cap is going to be cancelled out, and these are going to be add up now, right? Sorry,
Yes,
sorry,
ma'am.
sorry. Okay, I will write it down. It would become negative of m v by 2 I cap. Okay? And since we are talking about the change only, so basically this is your answer. Okay, the j cap components were going to cancel out each other. Is that fine? Okay, so let's check which option is going to, it's option A. The option A will match with our answer, right? It's option A. Okay, let's come to this question number 7, 2022 mein aaya hua question hai. Question says like this, ki we have a shell of mass m. It is at rest initially. Okay? It explodes into 3 fragments. It explodes into 3 fragments having mass ratio 2 ratio 2 ratio 1. If the fragments having equal masses fly off along mutually perpendicular directions with speed v, then find the speed of the third fragment. Let me share this question in a very simpler language. See, the question is like, we have a something, some block or some shell of weight m. Okay? It is at rest initially. Suddenly, it explodes and divided into 3 fragments. Okay? M1, M2, M3. They give you the ratio, which is 2 ratio 2 ratio 1, like this. They said this M1 and M2, they move or they fly away perpendicularly to each other with same velocity v. Find out the velocity of this m3 fragment. Do you get the question?
Yes, ma'am.
Take it.
Yes,
To
ma'am.
solve this question, you have 4 options over here, and I'm going to launch the poll. Okay, so time is up. I'm going to end the poll. Result is live for you also. Let's check it out. I've got 2 answers. It's B or C. Let's check which one is the correct one. So in these kind of questions, when there is no any external force that you have applied, so we would say ki external force is 0. If external force is 0, then momentum is going to be conserved. This is the basic principle, right? We need to follow it. On the basis of it, let's solve this question. Okay? So you can say ki ma'am, see, the basic thing which I really feel ki whenever you have ratios, just remove the fraction as much as you can. If I put m over here, if I consider the initial mass m, then I would go like this na ki 2 by 5m, 2 by 5 and m by 5 with the ratios, considering this 2 ratio 2 ratio 1. I don't like fractions with the ratio. So what would I do? I'll consider it as 5m. Because now if I'm going to, distribute it over the fragments, now they are the perfect numbers for me. So you can say, ma'am, it is 5m with 0 velocity. So this is the initial momentum. Since momentum is conserved, so initial momentum is supposed to be equals to the final momentum. You will get 2m. Let's say the 2m wala fragment is moving with v velocity in I cap direction. Now the question is, the another 2m fragment is supposed to be move in perpendicular direction, so it would be j cap, right? Put here m, and I don't know in which direction this third fragment would fly away. So I said it's v vector. Let's calculate it. In this order, you will get 0 is equals to 2m. Let's take v common. You will get I cap plus j cap plus m v vector. Okay. So wait a second. So I guess what? We can take m common and it would become 2v I cap plus j cap plus v cap v vector is equals to 0. Yes or no?
Yes, ma'am.
And from here, you can have v vector as negative of 2v I cap plus j cap. I think now we can calculate the magnitude. The magnitude of vector is very easy to calculate now. Can you do that for me? Just take this minus 2 inside and you will get minus 2 square plus minus 2 square, and you will get 4 plus 4, which would be 8, and it will come 2 root 2. 2 root 2 times of v, right? It is your option number C. Very nice. I really like you opt this option. Do you get the idea? Huh? Are you okay with
Yes,
this
ma'am.
question? Okay. This is very important because in the previous year, if you analyze the PYQs, I saved your time. I did that. So I feel we got a lot of questions from this kind of pattern, right? From the conservation of momentum. And especially this one. Two fragments are moving perpendicular to each other. Find the velocity of other one. So we have a lot of questions like that. So it is recommended to you. Please practice this question twice or thrice at least. Is that okay?
Yes, ma'am.
Okay. So let's do this question from 2019. And this would be the last question of today's session. Okay. I'll give you a few questions in the homework. Kindly do that too. It's 18:38 right now. You have 2 minutes to solve this question and then I will discuss. So let me read out this question for you. It says, an object flying in the air with velocity this suddenly breaks into two pieces whose masses are in the ratio 1:5. The smaller mass flies off with a velocity this. Find the velocity of the larger piece. Okay? So again, it is the question on the same pattern. And for you, the question, the poll is live. Kindly answer over there.
Done, ma'am.
Yes, time is up all and result is like full. Acha, I've got only one vote, and that's you, Harshita, right?
No, ma'am.
It's you, Misbah.
Yes, ma'am.
That's very good, Misbah. Can you explain the question? How we are going to solve this one? It is
Yes,
option
ma'am.
A actually. Yeah, please do the explanation. Misbah, will you explain the answer? How do you arrive at this option A?
Ma'am, 1 minute.
Okay, okay. Take your time.
As the object breaks in two pieces, so the momentum of the system will remain conserved. The total momentum before breaking is equal to total momentum. mv is equal to m upon 6 v1 plus 5m upon 6 v2 into v is equal to v1 upon 6 plus 5 v2 is upon 6
Okay, okay. I
given
get it. I get it. Cool, Misbah. Very nice. So what she did is basically this question said ki you have a mass, it break into two pieces of 1:5, right? Again, I said
Yes,
ki
ma'am.
avoid the fraction in the question. So you have total 6 now here. Consider it as 6m. So you will get this fragment of mass m and this fragment of 5m. Okay. See, if you involve fractions now, it will complicate your expression, right? So why are we going to do that? We don't like na complications. So we yes, Harshita, please go ahead.
Ma'am, will you explain the question?
The question is we have a block something m of some mass and it suddenly explodes. So when it turns, the word you get na sudden or without any external agency, then always go with this concept that external force is going to be zero and the momentum is going to be conserved, right?
Ma'am,
Now,
we have to compare the initial momentum and final momentum.
exactly. So what is the crux point of the question? Ki whenever you got na, the feeling ki you are not doing anything and still it explodes. So it means this suddenly break na. This is your hint to use the conservation of linear momentum and you should pick it up. Is that okay?
Yes, ma'am.
Okay. So the 6m is at rest, this m and this 5m. We have the information of m. We have the information about its velocity. We need to find out the velocity of heavier one, right? Yeah. Okay. So the initial is going to be 0 and it is going to be m times of v1. Whatever the vector you have here is 20 I cap plus 25 j cap minus 12 I cap. I'm not going to solve this question since I discussed the physics. Now it's basic mathematics and you should do it. Okay. Because if I'm doing the calculations for you now, then I'm not doing good as a teacher. You, if you're feeling it difficult, if you're finding maths difficult to solve, then it's your duty to do it. As much as you do it, as much as you practice it, you will be very fluent with it. Okay, you will be very comfortable with it. So please do it and find out this vector v2. Can you do that for me? You can take m common. It would going to going to be away from this equation. You will get it what? 20 I cap plus 25 j cap minus 16 k cap, okay, is equals to negative of what? Take a second. You will get negative of v2 vector. Is that okay? Hmm?
Yes, ma'am.
So I think you will get your answer. It would be minus 4 I cap minus 5 j cap minus 4 I cap. Wait a second, bhai. Huh. 5c20, it's क्या हुआ ये? Oh, sorry. We have an initial velocity here. We can't keep it at rest now. We have this initial velocity here. Yeah. And this is the final velocity of smaller one. है ना?
Yes, ma'am.
Yes, this is not at rest. Yeah, that's why I think it's so peculiar. Okay. So still you got the answer, not? That is the point. Still you have the answer. You know how to solve it. I will write the equation for you. You will solve it by yourself. 6m v vector is equals to m v1 vector plus 5m v2 vector. ठीक है? This is your v vector. This is your v1 vector and v2 vector is your option. Is that okay? Can you do that for me or yourself?
Yes, ma'am.
Yes, ma'am.
Okay. Now I'm going to solve let you know a few questions. These are your homework questions. Okay, these are your homework questions. I will not. I will upload this one. Okay, and share the solutions with you also. So if you find some particular question difficult to solve, then please feel free to ask. Okay, ma'am, I'm not
Ma'am,
comfortable with
will
this
you
question.
upload this PDF or share in the group?
I will upload it. Okay, I will
Okay,
always upload the PDFs. I will not share it in the groups. Okay,
okay,
you have
ma'am.
my Bitly link. You have your sheet link. You will find the
Yes,
file.
ma'am.
So these are very important. If you find something very difficult, please ask me. Otherwise, in next class, that is important. Na? We need to discuss what we will going to do in next class. In next class, we will continue our rotational motion. Okay?
Yes, ma'am.
Okay. Take care. So have a nice time ahead. It's really nice to teach you. Okay? Have a lovely time.
Thank you, ma'am.
Yeah. Bye.
Thank you, ma'am.
Thank you, ma'am.
Welcome, Vita.